Hi everyone. In this class, we are going to see a topic in differential calculus, namely continuity. First, we see the definition of continuity. A function f of x is continuous at a number a if limit extend to a f of x is equivalent to f of a. That is, a function is continuous at a particular point a if it should satisfy the three conditions, namely the first one, f of a is defined. That is, the function is defined at the particular point a. Second one, limit exists. That is, limit extend to a f of x exists. The third one, that limit is equivalent to f of a. That is, limit extend to a f of x is equivalent to f of a. So, a function satisfies the three conditions, then we can say that the function is continuous at the particular point a. A function f of x is continuous on an interval if it is continuous at every number in that interval. So, we defined function continuous at the particular point a. Similarly, we can define in an interval. That is, a function is continuous each and every point in that interval. We have a note: if f of x and g of x are continuous at a number a and c is any constant, then the following functions are also continuous at a. That is, the sum of two functions f of x plus g of x or difference of two functions f of x minus g of x is continuous. And c into f of x, c is any constant, so c into f of x is also continuous. And product of two functions, if f and g are continuous, then the product is also continuous, f of x into g of x. And the division f of x by g of x is also continuous, provided the denominator function g of x is not equivalent to 0. Second note, the following type of functions are continuous at every point in their domain. That is, all polynomial functions are continuous, rational functions are continuous, root functions are continuous. Root functions, a function having square roots, and trigonometric functions, namely sine, cos, tan, like that, and inverse trigonometric, sine inverse, cos inverse, and so on, and exponential functions, e power x, and logarithmic functions, log x, log of x plus 1, like that. So, these functions are all continuous at every point in their domain. Now, we see examples. First one, check whether the function f of x is continuous at x is equivalent to 2. The function is defined by, if x less than or equal to 2, the function is x cube minus 3. If x is greater than 2, the function is x square plus 1. So, we need to check the function is continuous or not at the point x is equivalent to 2. So, now here you can observe that. So, the function, we take the point x is equivalent to 2. So, if x is greater than 2, above 2, the function is nothing but x square plus 1. And if x is less than or equal to 2, the function is x cube minus 3. So, we have a splitter functions. We need to check at x is equivalent to 2. So, this point is nothing but the midpoint. So, we need to check limit and function value at this point. So, already we discussed about three conditions, right? So, the given solution we will see now. The given function we take as it is and find out function value at the point f of 2. So, f of 2, where we have f of 2 in this, okay, look at this in the given problem, x less than or is equivalent to 2. That is, x equal to 2 here. So, the corresponding function is x cube minus 3. So, f of 2 is equivalent to x cube minus 3. In this, we put x is equivalent to 2. So, 2 cube minus 3. So, we have 2 cube is nothing but 8. So, 8 minus 3 is nothing but 5. So, function value at the particular point is 5. And now, the second thing we have to find out the limits at x is equivalent to 2. So, here this is the midpoint. So, we need to find out the left hand limit as well as the right hand limit. So, now we first find the left hand limit. So, limit extend to 2 minus f of x. So, 2 minus is nothing but here, this side. So, what is the function? X cube minus 3. So, limit extend to 2 minus f of x is nothing but x cube minus 3. Now, we put x is equivalent to 2. So, we can get 2 cube minus 3, nothing but 5. So, left hand limit is nothing but 5. Similarly, we can find out the right hand limit. So, limit extend to 2 plus f of x is equivalent to limit extend to 2 plus. So above 2. So what is the above 2? Above 2, the function is nothing but x square plus 1. So we can substitute now x square plus 1 and put x is equivalent to 2. So 2 square plus 1, nothing but 5. So now here you can observe the left hand limit is 5 and also the right hand limit is also 5. So limit exists and both are equal. Therefore we can say limit exists and this value is nothing but 5. So here in case this is 1 and we can consider this is 2. So 1 is equivalent to 2. That is limit extended to f of x is equivalent to f of 2. Therefore we can say that the given function is continuous at the particular point x is equivalent to 2. Now we see the second example. Find the limit extend to 0 f of x. Also check the continuity for f of x at x is equivalent to 0. So here the given function is if x is less than 0, what we have, the function is x plus 2. At x is equivalent to 0, the function value is 0, and above 0, what we have, 2x plus 2. So here we can write at x is equivalent to 0, the function value is nothing but 0. If x is less than 0, what we have, x plus 2, and if x is greater than 0, what we have, 2x plus 2. Now the first thing is, so find out the right hand limit or left hand limit first. So here we have right hand limit extend to 0 plus f of x is equivalent to limit extend to 0. What about right hand side? So right hand side, what is the function? 2x plus 2. So here we can substitute 2x plus 2 and put x is equal to 0. This term becomes 0 plus 2. So we can get only 2. Similarly, in the left hand side, limit extend to 0 minus f of x. So 0 minus is nothing but this side, left hand limit. What is the function? X plus 2. So limit extend to 0, x plus 2. We put x is equal to 0, this term becomes 0, and we can get 0 plus 2 is nothing but only 2. So right hand limit exists and left hand limit exists and both are equal. Therefore we can say that limit exists, and we can write limit extend to 0, f of x is equivalent to 2. And now we have to check function value at x is equivalent to 0. So here look at the given problem, f of x is equivalent to 0 if x is equivalent to 0. So f of 0 is nothing but 0. So now check the continuity. What is the formula? So limit extend to a, f of x is equivalent to f of a. If this is done, then we can say the function is continuous at x is equivalent to a. So what we have now here, the limit value is 2, whereas the function value at x is equal to 0 is nothing but 0. So the condition is not satisfied. Therefore, the function is not continuous at x is equivalent to 0. Thus, f of x has discontinuity at x is equivalent to 0. Not continuity is nothing but discontinuity. Now we have a different problem. Problem number 3, we will see for what value of the constant c is the function f continuous on the real line, the interval minus infinity to plus infinity, provided f of x is nothing but cx square plus 2x if x less than 2, x cube minus cx if x greater than or equal to 2. So now what we are going to do, we have to find out the constant such that the function is continuous everywhere in the real line. So here the function is given like this, minus the interval is minus infinity to plus infinity, and the point x is equivalent to 2. So if x is less than 2, what we have? Cx square plus 2x. What about it? Above, if x greater than or equal to 2, what we have? X cube minus cx. So the function is continuous everywhere. We have to find out the constant value c. Right? So now these two are polynomials, right? Cx square plus 2x and x cube minus cx are polynomials in x. So therefore they are continuous everywhere in the real line. In particular, the function is continuous at x is equal to 2 also, because given f is continuous on the whole real line, therefore the function is continuous at x is equal to 2 also. So what is the meaning of continuity at the particular point? That is limit extend to limit extend to 2, f of x is equivalent to f of 2. So now we find out the left hand limit. Limit exists means what? Left hand limit exists as well as right hand limit exists, and both are equal. So first we have to find out the right hand limit. So limit extend to 2 plus f of x. So what about 2 plus? About 2, the function is nothing but x cube minus cx. So limit extend to 2, x cube minus cx. So we put x is equal to 2. So 2 cube minus c into x. So we can get 8 minus 2x. For we take this is equation number 1. And the left hand limit extend to 2 minus f of x is equivalent to limit extend to 2. What about 2 minus? 2 minus is nothing but the left hand limit. So the function is nothing but c x square plus 2x. So we have c x square plus 2x. We put x is equal to 2. What do you get? C 2 square plus 2 into 2. That is 4c plus 4. We take this is equation number 2. Now what is given? If f is continuous in the real line, therefore it is continuous at x is equal to 2 also. Therefore, the left hand limit is equivalent to right hand limit and is equivalent to f of 2. So now we equate equation 1 and 2 because left hand limit is equal to right hand limit. So we equate both. So we can get 8 minus 2c is equivalent to 4c plus c. So solving this, we can get 6c is equal to 4. Therefore, c is equivalent to 2 by 3. So in the given function, if we substitute c is equal to 2 by 2, the function is continuous everywhere in the real line. Similarly, we have one more problem. Suppose f of x is defined by like this. If x is less than 1, the function is a plus bx. If x is 1, the function is 4. If x is greater than 1, the function is b minus ax. And if limit extend to 1, f of x is equal to f of 1. So these two are given. What are the possible values of a and b? So here, what are the meaning of this? Limit extend to 1, f of x is equal to 1. What is the meaning? It shows that the limit is exist, okay, and is equal to f of 1, which means the function is continuous at x is equivalent to 1. So by using this, we are going to find out the values of a and b. So the given solution we will see, the given function is, we can take this, and here also we can see, take the whole real line minus infinity to plus infinity and take the point x is equivalent to 1. At x is equal to 1, the value is 4, and x less than 1, a plus bx, and right hand side b minus ax, that is above 1. So from the given limit extend to 1, f of x is equal to f of 1. From this, limit exists and the function is continuous at x is equivalent to 1. So from this, we can find out the left hand limit. Limit extend to 1 minus f of x. So limit extend to 1 minus, what about left hand limit? The function is nothing but a plus bx. So a plus bx, and we put x is equivalent to 1. What do you get? A plus b. Here if we take, this is equation number 1, and right hand side limit extend to 1 plus f of x. So above 1 plus is nothing but above 1 minus is nothing but below 1. So above 1, what is the function? B minus ax. So we can substitute b minus ax, and now we put x is equivalent to 1. So b minus a. So we can take this is equation number 2, and also f of 1. F of 1 is nothing but, so in the given problem, what we have? F of 1, x is equal to 1, function value is 4. Therefore, f of 1 is equivalent to 4. So given the function is continuous, so we have limit extend to 1, f of x is equal to f of 1. So therefore, we have left hand limit is equivalent to right hand limit, nothing but the limit is equivalent to f of 1. So equate equation 1 and 2, that is a plus b is equal to 4 and b minus a is equivalent to 4. So we can solve these two equations. We can get a is equal to 0 and b is equivalent to 4. So in this problem, what is the conclusion? In this problem, if we put a is equal to 0 and b is equal to 4, then the function is continuous at x is equivalent to 1. So the respective possible values of a and b are 0 and 4. Fifth problem, find the values of a and b such that the function f of x is continuous everywhere. Everywhere in nothing but in the real line minus infinity to plus infinity. So we need to find out the two constants. So here also we can see, take the whole real line. So minus infinity to plus infinity. So here the function is split into three functions, that is x is equivalent to 2 and x is equivalent to 3. So x less than 2, what is the function? 2 plus x. 2 to 3, the function is ax square minus bx plus 3. And above 3, we have 2x minus a plus b. So given the function is continuous everywhere on the real line, and in particular the function is continuous at x is equal to 2 and also x is equivalent to 3. So using this idea, we can find out the constants a and b. Now solution we will see. The first one we will see, if f is continuous everywhere in the real line, in particular the function is continuous at x is equal to 2 and x is equal to 3. That is, left hand limit and the right hand limit both are equal and is equivalent to f of 2. Similarly, left hand limit is equal to right hand limit is equal to f of 3. So now take the right hand limit, limit extend to 2 plus f of x. 2 plus is nothing but, what about here? The right hand side. So the function is above 2 is nothing but ax square minus bx plus 3. So we can have this, and we put x is equivalent to 2. So what we have? A into 2 square minus b into 2 plus 3. So that is 4a minus 2b plus 3. So we can have this right hand limit at x is equal to 2. Similarly, we can find out the left hand limit. Limit extend to 2 minus f of x. That is, limit extend to 2. What about the 2 minus? Below 2, the function is nothing but 2 minus x. Sorry, 2 plus x. So 2 plus x, and now we put x is equivalent to 2. What do you get? 2 plus 2, we have 4. So from equation 1, what we have? Left hand limit is equivalent to right hand limit. So we equate this to, we can get 4a minus 2b is equivalent to 1. We consider this is equation number 3. Similarly, at x is equivalent to 3, the function is continuous at x is equal to 3 also. So limit extend to 3 plus right hand limit. So limit extend to 3, 3 plus, that is above 3. Once again we go back, above 3, what is the function? So 2x minus a plus b. So 2x minus a plus b. Now we put x is equivalent to 3. So we can get 2 into 3 here minus a plus b, that is 6 minus a plus b. So consider this equation. And the left hand limit, limit extend to 3 minus f of x, that is limit extend to 3. What about 3 minus? Once again we go back the previous slide. So what do you get? 3 minus this one. So here ax square minus bx plus 3. So ax square minus bx plus 3. Now we put x is equivalent to 3. What do you get? A into 3 square minus b into 3 plus 3. So we simplify. We can get 9a minus 3b plus 3. And given the function is continuous at x is equivalent to 3. Therefore, left hand limit is equivalent to right hand limit. So we equate this. We can get 6 minus a plus b is equal to 9a minus 3b plus 3. And further we simplify, we can get 10a minus 4b is equivalent to 3. So consider equation number 4. Now as usual, we can find out or solving equation 3 and 4, two equations and two unknown. So solving this, we can get a value is 1 by 2 and b value is also 1 by 2. So two unknown, two equations. So easily we can solve, so that we can get a value is 1 by 2 and b value is also 1 by 2. So what is the conclusion? If a is equal to 1 by 2 and b is equal to 1 by 2, if you substitute these values in the given problem, then the function is continuous everywhere on the real line. Now we move to the next problem. Problem number 6. So this problem is also similar to the previous problem. Find the values of a and b such that the function f of x is continuous everywhere. So here also the function is split into three functions. So we consider minus infinity to plus infinity, right, at 2 points, x equivalent to 2 and x is equivalent to 3. So 2 minus the function is nothing but x cube minus 8 divided by x minus 2, and 2 to 3 the function is ax square minus bx plus 3, and above x greater than or equal to 3 the function is 2x minus a plus b. So the function is continuous everywhere this is given, therefore the function is continuous at x is equal to 2 and x is equal to 3 also. So using this idea we can find out the constants a and b. Now we will see the solution. So the given function is f of x we take, and the function is continuous on the whole real line. In particular it is continuous at x is equal to 2 also. So what is the meaning of continuity? Left hand limit is equivalent to right hand limit is equivalent to function value. So find out limit extend to 2 minus f of x. 2 minus f of x is equivalent to 2 plus. So first we find out 2 minus. What about the function? This one, x cube minus 8 by x minus 2. Once again we go back the previous one. So 2 minus. So here below 2 the function is x cube minus 8 divided by x minus 2. So we put x is equivalent to 2 here. If we put I think already we know how to apply the limits. So if we put limit x is equal to 2 directly, what do you get? 8 minus 8 divided by 2 minus 2. So we can get indeterminate form. So we try to factorize and cancel the common factors after we apply, so that we can get the value. So directly if we apply we can get indeterminate form. So the numerator we can use the formula a cube minus b cube. What about the formula a cube minus b cube? So a minus b into a square plus ab plus b square. So using this formula we can expand. So 8 is, how will you write? 8 is nothing but 2 cube. So x minus 2 a minus b, x minus 2 into x square plus 2x plus 4 divided by x minus 2. So now x minus 2 cancel. So the numerator function only we are having. So x square plus 2x plus 4. Now we put x is equivalent to 2. So x square is nothing but 4. 2 into 2 is nothing but 4, and already constant is 4. So we simplify, we can get 12. And the right hand limit extend to 2 plus f of x. So given limit extend to 2 plus about 2. So what we have? Once again we go back the previous slide. So about 2 here, about 2 is nothing but ax square minus bx plus 3. So we can write this function ax square minus bx plus 3, and now we put x is equivalent to 2. So x square, 2 square is nothing but 4. So 4a, we put x equal to 2. So 2b plus 3. So now both are equal. Left hand limit is equal to right hand limit. Therefore, what do you get here? So 4a minus 2b plus 3 is equal to 12. So we simplify this, we can get 4a minus 2b. That 3 we take into that side, we can get 12 minus 3, nothing but 9. So we take it as equation number 1. Similarly, the function is continuous at x is equal to 3 also. So therefore left hand limit is equivalent to right hand limit. So now we find out the left hand limit. So limit extend to 3 minus f of x. So see the problem, 3 minus, below 3 the function is nothing but ax square minus bx plus c. So now we put x is equivalent to 3. So 3x square, 3 square is 9. So 9a minus 3b plus 3. And right hand limit extend to 3 plus f of x. Above 3, see the given problem, the function is nothing but 2x minus a plus b. So now we put x is equivalent to 3. So we put x equal to 3, 2 into 3 is nothing but 6 and minus a plus b. And using this, what we have? Both are equal. Therefore, 9a minus 3b plus 3 is equivalent to 6 minus a plus b. So we simplify this, we can get 10a minus 4b is equivalent to 3. So now take equation number 1 and equation number 2. So we have two equations and two unknown. So we know how to solve two equations and two unknown. So we solving this two, we can get A is equivalent to minus 15 by 5 and B is equivalent to minus 39 by 2. So from this what we conclude? So if A is equivalent to minus 15 by 2 and B is equal to minus 39 by 2, so take this two value and substitute in the given function such that the function is continuous everywhere on the real line, namely minus infinity to plus infinity. Thank you for watching. Please like, share and subscribe. Thank you.